Dear students, I welcome you all for the online learning platform for the course Warehousing Automation. So this presentation will take us to a new chapter in Unit 4 Decision Making Process in Warehouse. So today's topic of discussion is going to be decision trees. So Unit 4 basically deals with decision making processes in warehousing automation. So in this context, the first half of the unit discussed a lot with respect to the purpose, the need, the necessity, objectives, how to set a decision, how to develop design as well as develop a decision support system was all discussed in detail. Then followed by an optimal deployment strategy was the discussion on what basis we should go ahead with. So from the summary of this, it is very clear that the decision making what we make ahead go ahead should be based on rational thinking, a logical thinking should be there, not based on emotions. So these all are the things what we discussed. The second half of the unit discusses about the various tools and techniques available for decision making. So initially we discussed about SWOT, then followed by cost benefit analysis, and this presentation will take us to decision trees. So with this recap, directly we'll get into the decision trees topic. A decision tree. See, the first concept of SWOT analysis was a tug of war between the positive versus negative. So that is what we just had our discussions. Then the next was purely into the context of, into the perspective of finance, where the cost aspect and the benefit aspects was discussed. So direct cost, indirect cost, opportunist cost, then intangible costs were calculated, and we need to go ahead with a thorough understanding of the system. Then only we will be able to be carry out the cost benefit analysis. So this is what the learning we had. So now with the advancement of technologies, even some cases we should go ahead with a graphical understanding. So how the system branches out. So see, it's a very general understanding that rather than going ahead with the vocabulary pages together, if the same thing is represented into an image or a graphical representation, so the level of understanding, the level of interpretation as well as the implication of the data is going to be very effective. So this concept is known. One simple example, say in a class of 50 students or 60 students are there. Once their marks for one particular subject has been released, you just go ahead with their name list right from 1 to 60. You can't come out with a clear clarity. But the same thing if it is represented in the form of a bar chart or a line chart, so we'll be able to clearly distinguish the phenomenon, how the class has performed, what's a major mark, what is a minor mark, so maximum versus minor, then with respect to the average, how the class has performed. Likewise, we can get n number of data once if it is pictorially represented. So decision tree is of that particular nature, so where it is going to give out our choices as far as decisions are concerned. So with this preamble, we'll just get into the decision trees. So a decision tree helps us to make decisions by mapping out different choices and their possibilities and their possible outcomes. So how to understand this? See, first and foremost thing is we have got an objective here. So our objective is going to be, so selection of a robot or selection of an ASRS system or selection of power for an ASRS system, say hydraulic or mechanical, or we wanted to go ahead with electrical. Likewise, when we have got an option, so how the decision branches out, under what constraints or under what considerations that particular option has been discarded, or under what conditions one particular option has been chosen. So likewise, we wanted to know the total comprehensive picture, the aggregate picture. Okay, it's going to be a representation on a simple basis. So that is what decision tree is all about. So basically it is a machine learning for tasks like classification and prediction. So usually it is an ML algorithm, so which is used for classification and prediction as well. It is used even in the case of decision making. A decision tree helps us make decisions by showing different options and how they are related. So this is what is quite interesting part. The interrelationship between various options available for one common goal. For one common problem, there are multiple solutions are there. What are the interrelationships between them has to be known clearly so that we can draw maximum amount of inference from it. It has a tree-like structure that starts with one main question called the root node which represents the entire data. So the term decision trees, how it has come means, see, the basic purpose of application is for the case of decision, that is decision making. And the term tree, why it has been given tree is, it is going to look like a form of a tree. See, a tree means basically it has a stem from the root, that is subsurface, post the surface, it has got a stem, and these stems are going to branch out, and again these branches are going to get into sub branches. So likewise it just converges. So that's the reason it has been given with the term trees. So the main stem of the tree, okay, or the trunk of the tree is called as root node as far as the decision tree is concerned. So that is going to be called as the entire main data set. So from there, tree branches out with different possibilities based on features in the data. So based on the nature of the problem, based on the data what we have, so it is going to branch out. So we'll see the basic terminologies involved. Root node, starting point representing the whole data. So root node is, see, root is the one which is going to act as a single point of contact for the entire structure of the tree to the ground with respect to the soil. So that is the one which is going to act as a connecting member. So therefore here root node, starting point representing the whole data. So that is data set. That's where the entire problem starts. Branches, lines connecting nodes showing the flow from one decision to another. So first let me put a very simple example. We have got two robots. So robot number one is, say, a SCARA robot is there. Robot number two is, we have got an articulated joint robot is there. So now the problem is which robot has to be chosen, either to go with SCARA or to go ahead with an articulated joint robot. Now the problem is selection of the robot. Okay, now it is going to branch out because you have got two options. So two branches are going to come. So the left arm, okay, the left arm is going to, that is the left branch is going to represent the SCARA robot, the right branch is going to represent the articulated joint robot. So that's how the problem initially it gets deviated. So further from one branch, again sub branches are going to come out. So internal nodes, points where decisions are made based on data features. So based on the data set, based on the options, it has got bifurcated. So it is going to, again, it is going to lead to the next further nodes. Leaf nodes, end points of the tree where the final decision or prediction is made. So leaf node is, that's the end. That's the end. See, root it has started, then it came for branches, then it went into from the root it went into branches, again branches got into internal node, and the end, that's it. Henceforth, after the leaf node has been attained, no more further development of the problem is there. That is, the decision has been arrived. So this is how initially it goes ahead with. So root node we have got. So from there branches out, then we get the leaf node. So that's the problem structure. This is a minimum requirement. Only we have got two layers. Layer number one is for root node and the layer number two is for the leaf node. So this is in a very elaborate case. Now let us go for our example. So root node here is selection of the robot. So for the left, that is we are going to have a SCARA robot. To the right, we will have the articulated joint. So SCARA robot, what all are the reasons for selection? Reason number one, reason number two. That is leaf node 1, leaf node 2. Similarly, for the next one, leaf node 2, leaf node 3. So likewise, we can expand. We can go ahead with the converging of the problem. So decision tree also helps with the decision making by showing possible outcomes clearly. Okay, see, it is not going to just give the decision, final decision. It will also show the way how that particular point has been arrived. See, earlier cases it was mere comparison. What are the things we studied, that is a SWOT as well as a CBA, they were just mere comparison, but they never showed the logical reasons behind it. It was something based on the consensus of a team. Okay, and the former case, that is the later case, cost benefit was purely with respect to cost. So this is going to give still more a clarity so that we can go ahead with a very prompt as well as a proper decision, a logical, viable as well as best solution will be able to arrive. By looking at the branches, we can quickly compare options and figure out the best choice. Okay, so it is not going to give you the thing, it will show you the all the options and it will give weightage for individual things, and it is left to the user to go ahead with the selection of the best choice. There are mainly two types of decision trees based on the target variable. So the first type is classification variable used for predicting categorical outcomes like spam or not spam. These trees split the data based on the features to classify the data into predefined categories. Okay, so it is an simple example where you got a mail. So that mail, whether it is important or unimportant. Okay, so how to go ahead is there will be set of platforms will be there, predefined categories against which it will be evaluated and the decisions will be arrived. So classification tree is one example, one type. And the second type is regression trees. So used for predicting continuous outcomes like predicting house prices. Instead of assigning categories, it provides numerical predictions based on the input feature. So usually regression, the term regression means it's a mathematical equation. So regression, out of regression analysis, it is going to map the relation between the input versus output variables. So students, at this junction, you can see the role of coding, say Python coding, say matplotlib or several pylib. There are several codes or they related to it. So in your honors course, anyhow, at the end of your 6 courses, there is 1-2 credit lab is there. That is, a mini project has to be taken care. So think of using such tools as applied to our own automation related things or with respect to any engineering applications in our own field of application. So think in such areas. So you need not to worry for a mini project at the later cases. Right now you can do the spade work and you can be strong in this particular regard. Okay, so the regression tree, it uses a regression analysis and a mathematical model is going to be there between the correlation between the input and output is going to be thoroughly mapped, and using that we are going to get the prediction. Now we'll see one by one. So working of decision trees, start with root node. It begins with the main question at the root node, which is derived from the dataset features. Ask yes/no questions. So questioning methodology is going to be implemented here. From the root, the tree asks a series of yes/no questions to split the data into subset based on specific attributes. So initially it starts into the root, then questions are there. Based on this questioning methodology, the subsplitting is going to occur. Branching based on answers. Each question leads to different branches. If the answer is yes, the tree follows one path. If the answer is no, the tree follows another path. So that's how the branching goes. If it is yes, say something like a decision making. No, we have got in a flow chart where we go a rhombus. If the decision is yes, go like this. If not, go to the right, or no node likewise. So here also the branching is going to occur. Continue splitting. This branching continues through further decision, helps in reducing the data shown step by step. Reach the leaf node. The process ends where there are no more useful questions to ask, leading to the leaf node where the final decision or prediction is made. So what happens is, in the fourth step, it is going to continue with the same methodology. So once, if there are no more questions, then it reaches the end. That is, the problem is getting ready for the case of termination. So such thing is called as termination criteria. That means a leaf node has been attained. So this is how it goes on. So root node is going to be the question. So now our question in this case will be whether to select Scala robot or to go ahead with the articulated joint robot. So we'll have a questions. Here we'll have a questions whether the robot is having multi-axis possibility. If that is a question given for this particular case, then for Scala robot it will tell only for X, Y it is possible. For Z axis there is no rotation possible. Whereas when we come for articulated joint, so as such there are no constraints. It can take up all sorts of axes across all degrees except 100% revolution it can go ahead with. So likewise, based on this decision, yes, no will be occurring. Then second, load lifting capacity, or with respect to the velocity of operation. So likewise, we can go ahead with the experience of the shop floor will be made into the form of questionnaires, and from there the branching out or the process is going to be developed. So now as we discussed both these cases in a one particular image. So classification tree, so it is going to classify whether yes or no. That is the question, there are some predefined categories are there. So against these categories, the problem is going to be analyzed and it is going to get bifurcated, and based on that the classification is done. Yes or no only will be the answer. Whereas when we come for regression tree, so regression tree means a numerical split will be occurring. So here we will be having some questionnaire. So based on that the data is going to split and prediction is possible. What is the reason for prediction is mathematical equation is available. What does this mathematical equation represents is it is going to represent the input versus the output variable. The relation between the input versus output variable is going to be promptly present. Henceforth regression analysis is going to be a step ahead when compared to classical classification tree with respect to decision making process. So advantages, so easy to understand, decision trees are visual which makes it easy to follow the decision making process. See, SWOT means we should study everything, what all are the strengths are there, what all are the weaknesses are there, what all are the opportunities, what all are the threats are there, and some cases that actual perception might not be consumed or conceived by the person who studies. See, the person who was prepared would have kept in his own mind, under his own assumptions he would have wrote a statement. In the same context, we can't expect even the other people also to go ahead or to read in the same way. So there are some sort of possibilities or high. And coming for the next case, cost benefit analysis, you would have left some costs, or the data what you have collected would have been vague, or some cases it would have been imprecise. So under those scenarios, those tools and techniques require some sort of basic skill set to understand them. Perhaps when you come for decision tree, we don't have any sort of reservations as far as the decision trees are concerned. Why? Because it's a simple graphical representation. So it becomes very easy to understand and no prerequisite knowledge is essential. So versatility can be used for both classification and regression problems. So one tool, it can be used for two purposes, not only for prediction, even for classification, and at the end this prediction can be extended for even decision making problems. No need for future scaling. Okay, no need for feature scaling. Unlike many machine learning models, it do not require us to scale or to normalize our data. So I'll just give you one example in this normalized data. See, normalizing data is going to be one crucial aspect where we should convert the data between 0 to 1. So what is this 0 to 1? I'll give you a very simple example. See, as I told you in the previous discussions, there is a class of 60 students strength. So the minimum marks scored by the student is say 50 and the maximum mark scored by the student is say 95. So 50 to 95, this is the range, and within which all the 58 students marks are there in this particular regard. So I'll come again. So 60 students are there, the minimum marks are 50 in the class and the maximum marks are 95 in the class. So between 50 to 95, all the other 58 students marks are there. So there are some machine learning models, you give the data as such to them, they will not be recognizing. So what has to be done is, we are supposed to normalize the data. So what does this normalizing the data means? Convert all the values between 0 to 1. How to convert this? 50 will be considered as 0 and 95 will be considered as 1, and the data will be normalized. There is a formula. So substituting that formula, we will be converting all these things. So after post processing, that is normalizing, what happens? All the data will be 0 to 1. You use it into the machine learning algorithm, you do all sorts of calculation, you get the results. Output also will be between 0 to 1, and what ought to be done is we need to denormalize it again. So you denormalize it, what happens is again we get the data into the regular form. So that normalization problem is there in many algorithms, and I will give you one more tip in this regard. See, when you go ahead with MATLAB, the versions which are less than 2008 alpha, 2008A, MATLAB older versions, all the toolbox capabilities were having the feature of normalizing. All the data should be normalized, then only you should use. But after 2010, that thing has been abandoned. So that is no more there. That has been abolished, and you can go ahead. But still, there are some models for which data has to be normalized. Handles non-linear relationship. It captures complex non-linear relationship between features and outcomes effectively. Interpretability. The tree structure is easy to interpret helps in allowing users to understand the reasoning behind each decision. See, non-linear relationship is going to be one of a tougher task when you get into decision trees. See, when you plot the data into a graph, so if the relations are linear, so it is very easy. But if it is in an exponential case, or if it is in the logarithmic case, or if it is in the order of nth order of polynomial, say second order, third order, it will be something like sinusoidal. So the problem gets complicated. So therefore, non-linear relations are easily handled by decision trees. Interpretably, see, as I told you earlier, it's a graphical representation. It is not only easy to understand, even we can draw inferences out of the tree. Handles missing data. It can handle missing values by using strategies like assigning the most common value or ignoring the missing data during splits. So usually there is one thing called as a data munjik, where the unstructured problem is made to a structured category. So where the missing values has to be dealt, or it has to be treated in a different case. So even that is also possible in this particular decision tree. So now we are in the end of the presentation. So this presentation, this video lecture took us to an interesting topic under machine learning category called as a decision tree. So the decision tree is not only used for machine learning models, even it is used for the application of decision making. So there are two types of the decision trees are there. The first is classification tree and the second thing is a regression tree. So classification tree is going to work based on set of questions, and decision tree is also going to work on set of questions, but the thing is it is going to used for predictive application because of the mathematical relation between the input versus the output. So the term regression itself tells the term regression analysis. Then we discussed about the decision tree structure. It starts with the root node, then based on the question it branches out, then it gets into the leaf node. Till then it is going to answer series of questions at various level, and leaf nodes are going to give you the weightage of various options. So these all are the things what we discussed, and finally we just appraised the advantages of this particular tool as general. Okay, not comparing, as general we discussed about the decision trees advantages. So with this presentation we come to the end of this topic, decision trees. So in next presentation we will see another important topic by name Pareto analysis. So with this I come to the end. So thank you students. So before I wind, any doubts please note it down. We shall discuss the same in our offline classes or during our online discussions, or still you have got doubt, please contact me so that it can be clarified. Okay, thank you students. Thank you for your active participation. Thank you.